So we're going to kind of talk about GPS systems, and what I'm noticing when I've gone to conferences lately is people don't refer to them any longer as a GPS system. They're referring to them more and more often as a Gnss, because GPS refers just to the United States system of satellites, and GNSS means kind of the whole global network. And so people, because the Russians have opened up theirs and there's a couple others coming online, I think France has a big one and India has another system, because those are coming online, they're just using the term more often as global navigation satellite systems. So you need three components to have these things work, and one is that satellite constellation, and you need the receiver, is the handheld piece, and then you need the ground station. And the satellites that we use for GPS collection are what are called active satellites. They're sending out a radio signal. We have lots of remote sensing devices. Our eyes are remote sensing devices, and they don't send out an active signal. They just receive information. Cameras are basically passive. They don't send out a signal. They receive a signal. But satellites can be both. And the satellites that we're using send out this radio signal that gets picked up by your receiver, by your GPS receiver. And then there's a system of ground stations that do the correction, that manage the system. So you need all three. So we're talking about 24 satellites, although the reading said there are now 27 that are active, but they have a system of 24 satellites that circle the Earth twice a day. And they're positioned so that at any point in the day, or any place in the world, you can see 4 satellites. And that's the way those orbits are set up. And they move pretty fast. We've got those 3 for backup, but apparently those are online. This is a dying system in the U.S., and most of the satellites are really old, and we don't have apparently the budget that's keeping them kind of repaired and up, and new ones going up. And when you think about what we rely on right now for this imagery, for the new thing I'm hoping they'll do is satellite phones. But they're critical right now to the way that we live, and for weather, for navigation, for military, for Facebook, for your phone. So it's really important, and yet there's not been a lot of funding to keep them going. The Russian satellite system is fully operational, called GLONASS, and our units are older. And so they are not set up to pick up the European Galileo system. And then China has a system called COMPASS, although after this week they may not let us they may not let us read their stuff. We're having a little bit of posturing going on right now in the China Sea, which Korea would like to be called something different. India has a system, and then France has DORIS. Isn't that a great French name? And wouldn't you just expect the French to have a satellite system named DORIS? People refer to these as man-made stars. I don't know if they still do, but that's what they used to. And so this is an old fact. So the reading talked about the military satellite system has a much more accurate reading and then or resolution. And what I got from the reading is that's not exactly true. We have the same access. They just have more powerful correctors and could get through the atmosphere and can clean it up better. And I'm not sure that's true, but that's what they're telling us. So that's where we go with that. So this is kind of this nice little image of the satellites, blah, blah, blah. So the satellites send out a key. It tells you, your unit kind of where it is, what time it is, and the date. And so these are solar powered so that they can still send out signals when they're on the dark side. And they have an atomic clock, not an atomic bomb, which, did anybody laugh? Does anybody laugh at these things sometimes? Thank you. Thank you, thank you. I just get bored writing the questions, so sometimes I make up stuff. Anyway, so they have that atomic clock that's supposed to keep them, ridiculously accurate. So that's kind of the satellite system. Then there's this system of ground stations. There's a master control, and we have a backup control. The master control station's in Colorado, and then there are several unstaffed monitoring stations and some large antenna stations. I think now there are 6 ground antenna stations, or maybe more, now that we're using global systems. I think it said 16, something like that. I won't ask you to know that detail. So the control stations, they track, they send back information to the master system that can make adjustments to their navigation if they get kind of off a little bit. It can also tell them where they want them to go. You can change, the master system can change that location. There's a satellite system owned by a private company. It's called GOI, and you can buy it. You can rent time, and so when there was active conflict in Sudan, GOI was purchased by, I believe, the UN. They purchased time and asked them to change their orbit so that they could get some confirmation images of the active burning of villages in Darfur. And so even though the North Sudanese government at the time was denying that there was any conflict going on, they were able to get really clear satellite images to prove that, yeah, there was, systematic on-the-ground conflict. So the 24 stations that we have, 27 stations that we have a constant orbit, but they could be changed depending on shifts or needs. Okay. So our receiver is passive, and in order to get a good signal, you need an unobstructed view of the sky. So when we turn these on, it will keep telling you, I don't have a satellite signal. I don't have a satellite signal. And we say, yes, we know that. But they also don't do great in a heavily forested area. They don't do great when you're really close to a building, because they basically, radio signal is kind of line of sight, right? And so you need a really clear, unobstructed view of the sky to get the best reading. And so you can block it by your body. So there's some ways to collect that are systematic and that are helpful. You can have antenna. Sometimes there are units that have a really tall antenna in a backpack that will kind of get higher up. So these do not have a high antenna for that. So let's see. So they use that distance time rate, distance time speed, distance time rate formula. And so I think it's just kind of amazing that these little GPS units have a calculator that can receive that signal. The computer, the satellite sends out, this is where I am, this is what time it is. You pick it up and you say, well, this is, based on these guys, they're telling me where I am. And the computer knows how long it takes a signal to travel a certain distance, because each computer tells you or each satellite tells you how far above the surface it is. The satellite, or the GPS unit, knows how to figure out that distance, what would be the lag time in speed that it took to get there, and then can calculate the accurate distance, which is just kind of very cool, and a good thing we don't have to do that anymore. Anyway, let's see. So one of the things that in the video we'll watch in a minute, he talks about needing 3 satellites, which is technically true. You need 3 satellite images to locate your position on the Earth, but you need the 4th to locate elevation. Okay? And so the idea is that if you draw a circle, let's say there's some kind of machine that says there's this guy running around, maybe he's got one of those ankle bracelets on, right? And it says, I can kind of beep where he is, and I only know that he's somewhere. He's 10 miles away from me. So from where I am, if I draw a circle, he's somewhere on that 10 miles. I don't know exactly where it is. So if I have someone else tracking him in another place, and that person says, well, he's only 3 miles from me, where those two circles intersect, that guy's on one of those two places. So now I know where he is. You know, I could get a 50% guess. But if I have a third person tracking that says he's 15 miles from me, where those 3 circles intersect, that's the pinpoint location where that person is. And the fourth would be, because we're working on a sphere and not a flat plane, can give you that elevation. So, because I love, I can't show this because it's not in animation form, but with the first circle, all I know is he's somewhere on this purple ring. With the second circle, I know that he's here or here, and with the third, I can pinpoint that location. So that would be triangulation, right? So I have 3, but we do trilateral, because we need 4 to get that vertical distance, okay? That's the difference between 3 and 4. So in the olden days, the GPS unit would pop on as soon as it read 3 satellites. It had the good reading of 3 satellites. And I don't remember now whether ours will pop on with 3 or until it gets 4. So you guys will figure that out today. Okay. When you're going to collect your data, it's a good idea to know what your end product wants to look like. So if I'm working for Oregon Department of Transportation, they probably do all of their collecting in the state plane coordinate system. So I might want to set my GPS to collect the data in that same coordinate system. If you don't know, we're going to collect in a geographic coordinate system that's not projected. So we're going to set our datum and our spheroid to WGS 84. So we're not going to use a projection. When you bring your data in to your computer in a computer program, you need to make sure that you know what your projection or not projection, what your coordinates were set up, what the setup was when you bring it into the interfacing program. So, because if there's a mismatch, then your data might not work. When we use a program called DNR GPS, and DNR GPS was developed in Minnesota, and it's a free software. And because it was developed in Minnesota, they defaulted the coordinates to the Minnesota State Plane Coordinate System. So when we would bring our data in from unprojected data into the Minnesota system, all of our points would be off. And it took us a little while to realize, so we had to change the DNR GPS to unprojected and then bring our data in as unprojected, and then our points lined up. So you may get a little bit of misalignment because I think there's like 49-foot accuracy with these. But if you're like in the next city or 100 feet away, then you want to start looking at, was this point blocked by a building? Is my coordinate systems, are they matching up? You have to look at all of that kinds of stuff. Okay, so there's lots of things that will deflect your signal. Sometimes you can get ricocheting inside like a canyon or between tall buildings, and so that will give you a really funny reading on your GPS. It's called multipath. So you can have the delayed signal, cloud cover, so we may get some funny signals today because it's a little bit foggy, satellite errors, and probably one of the biggest is owner-operator. You need to wait. When you go out, you've got to wait for your GPS unit to kind of settle in. You can't just walk and click, click, click. You can, but they're not as accurate. So if you give a little wait time, you can let that settle down. There's a method of collecting so that you're facing the same direction each time, so that you're holding it the same distance. All of these kind of seem like really small methods, but the more you can have a systematic approach, the better your data collection will be. So there are some ways to I want to go to this one first, to help correct GPS. So as I said, 49 feet is kind of the manufacturer's recommendation, or I don't know, recommendation is not the word, but I can't think of the word. It's what they say the distance accuracy will be, the horizontal accuracy. But you can get a lot closer, maybe 30 feet or so. And then if you use some of the differential corrections, you can get even closer. So these units have a differential correction system that automatically, if you choose that, will automatically help correct your data. We use something called WAAS-enabled, and we'll talk about that in a second. And then with the larger units, we would do something called post-processing, which means that because I live in Eugene, I would go find online, I would find a receiving station that was nearby, so maybe in Corvallis or in Springfield, that had a much accurate system. And I could say, okay, what would your reading have been, you know, at this time of day from this system? And they will correct your points. So we used some Trimble units when we were mapping the campus, and all of our points were off kind of north and northeast a bit, maybe 12 feet in some places. And when we did the differential correction, it just absolutely moved all of those points just almost dead on alignment. So, but we can't post-process with these. This doesn't have that, but it does have an onboard processor, and that is down one. So what these have is the ability to activate the WAAS system, and that's called the Wide Area Augmentation System. And this is involves 2 satellites in the southern hemisphere, and their system, their orbit is standard. So they stay in that southern hemisphere, and what happens is the GPS unit gets the regular satellites, and then it looks to those highly non-moving satellite systems of the WAAS, and then corrects your points automatically. But in order to get the WAAS, your antenna has to be able to see the WAAS, which means when at all possible, you need to face south when you collect your points, or hold it over your head so that it can read in a 360. If you hold it, you know, chest level when you're collecting, and you're facing north, it's not going to get those WAAS points, or that WAAS correction. So they're at a very low altitude, and they're highly correct. So we're going to maybe pause this video. So seriously, I moved that. Hold on, let's go back. Blah blah blah. There we go. All right. So what I want you to do is to turn on your Garmin. Okay, so the on-off button is that lower button on the left, the right as you're looking at the screen. Okay, so you're going to turn it on, and if yours flashes on and then jumps back off, you know that your battery needs fixing. And sometimes when you turn it on, it will default right to the battery and let you see how the battery life is. If not, I'll show you in a minute how to get to that. So that's the on and off button. Anybody have trouble with on and off? We're all good with on and off. Okay. Nope. Oh, okay. So then once you get your GPS unit on, we're going to do some settings. And so the menu button is on the left, which will give you kind of this screen. Okay, something like that. And the little button at the top is a toggle and a push down button. So you can move the toggle up, down, left, right to change your screen image, and then when you find a screen that you want, like if I wanted to open up maps, then I would push straight down on the toggle. So we're going to toggle around until you find something called the setup menu, and it's a picture of a little box wrench. And it does this little beep, 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 beep the whole time. Okay, and when you get to the box wrench, you're just going to push down on the toggle to open up that set of menus, and you'll see a bunch of other menus in there. And the one we want to go to first is the system menu. So you're going to toggle, this is the toggle. Oh, okay. That's what you're going to toggle around until you get to set up, and then push that, and then, yeah. And then we're going to open up the system menu. And mine, the first thing it says on mine is satellite system, and mine is in demo mode, which means when I go outside, it is not going to collect any points. So, John, is yours not working, or? Oh, well, John, so it might need batteries, or it might need, you can trade out. So here's another one. Why don't we trade? Yeah, thank you. And there are batteries here if it's a battery issue. So if you've... so make sure you change your name on the thing when you do that. Okay. I can't see that far. It would be nice if I could. Okay, so what you're going to go is in... did you need batteries?
It turns on when I plug it into the computer.
Well, yeah, because it's getting the power, so it's probably a battery issue. You bet. So you need the old ones, and I'll throw those where they go. Okay. So under satellite system, you want to choose, so you're going to push that, so you can open that up. You want to make sure you are set to GPS and GLONASS. If, as I said, if you're set on demo, you can't collect any points. Okay, so you want to make sure you're on that. And then you want to toggle down. Nope, you push it when it says GLONASS to set that. And so now you should only see under satellite system, it should say GPS and GLONASS. And then you're going to toggle down to WAAS. And you want to make sure that is on. And then you can use your back button and find the units. So we're still in setup. So we're setting up the computer or the GPS unit. And under units, I don't care how you collect your data. If you want to collect in feet, meters, doesn't matter. You can change that however you like. And then you're going to go back and change, go to position format.
Is this all going to be for naught if I change batteries?
No, it'll save it. So under position format, you want to make sure that you're collecting your data in HDD.DDDD, which is hemisphere decibel degrees. So that means it's negative for Western Hemisphere, positive for the Eastern Hemisphere. If you collect your data in minutes and seconds, you have to convert it later in order to get it into ArcGIS or Google Earth. So it's much nicer to collect in decimal degrees. Okay. We're not there yet. I'm sorry. Go ahead. Yes. ArcGIS, yeah, everything has to be in decimal degrees, and converting is kind of a pain. It's doable, but it's a pain. So then scroll down to map data, make sure you are set to WGS 84. And then make sure your spheroid is WGS 84. Okay? So this way you will sync with the DNR GPS. Okay. Okay, so you can go back and back twice so that you're at the main menu. So when we we're gonna remove actually any waypoints that are in here. So in the main menu, I want you to find Track Waypoint Manager, and Waypoint Manager has a little red flag with a white maybe folder behind it, and open that. And if you have previous waypoints, they should show up in your list.
On the track manager.
Yep. Waypoint Manager. You got a whole bunch. So you're going to push this bottom menu button all the way down to delete all. Okay, you got them? Okay, so you're going to push the menu button on the left. And just say no, don't continue looking right now. Oh, does it put it back in demo? Good finding. Okay, then we'll have to go back and fix that. How does it do that?
Probably just realize that it can't be connected to GPS right now, so.
Huh. Okay, that's good to know.
Probably saves battery.
Yeah, maybe. Good thinking. Okay, so you got them? Okay, so you want to get rid of all of those. And then you're going to go back, and I guess you're going to go back to settings. That is fascinating. System. So demo mode, it should stay if I set it.
When I set mine earlier, it automatically went back. And then
Oh, you know what? You know what it is? Because I said no. Keep looking for satellites.
Oh, I hit no too.
Yeah, I bet if I said yes, it would have stayed on there, which is kind of dumb. So that's a good point. Okay. Okay, that's probably the trick there. So when we go outside, we're going to go back and double check our setup settings that we're not in demo mode anymore. And then when we get ready to collect your satellites, you're going to go to the main menu. And somewhere in here is the thing called satellite. And this is what he was talking about. That bigger circle here is the horizon. The inner circle is the 45-degree angle. And the bars are the strength of the satellites that the unit is picking up. And you can see the arrangement of the satellites in the sky. So right here, it's not a great alignment because I don't have any down in that southwest or southeast corner. So once your satellites kick in, then your reading, your lat long will show up. That won't show up until it can actually read your satellites. And this gives you kind of your error. It says a 5-meter error, and this gives you your elevation in general of where you are. As you take your waypoints, that will also collect that. Yes, Billy?
If you were standing in one position and you started turning 360, would those circles start to turn also, or is that like a standard north, south, east, west?
I don't know. You figure that, tell us that. I never thought about it. That's a great question. I don't know about that. So what we're going to do for the lab is you guys are going to collect. Oh, did I close it or not?